So let's go ahead and get started. What I would like to do is I'd like to spend a little bit of time talking about virtualization and software containers. I would like to talk about these from the perspective of what is a software container, what is the use cases of where I'd want to do a software containers, and why is that so popular today. Now, you may not be familiar with the concept of a software container, but you probably have heard or maybe even used a couple of tools that are very commonly used within the container space. The two tools that you may be aware of is one called Docker and another called Kubernetes. And we're going to talk about what both of these tools are and kind of their role in the software landscape, the software container landscape. All right, excellent. So we're going to start with server host virtualization. What is virtualization? So what is virtualization? Now, the easiest way to think about this is, let's think about this from the perspective of, for the sake of the next few minutes, all of you are part of an IT department. And your job is to help us run our company. And we're going to kind of look at this from a historical journey. And so if we were to go back in time, and here I'm really talking, probably early 2000s. If you were part of my IT department, and what we were trying to do was to meet the needs of our employees, whenever someone had a service or an application they need to deploy, a lot of times what we would do is we would take that service, buy a piece of hardware, and deploy it. Oh, I need an email server. Okay, well, let me build you an email server. It's a dedicated server, it's a dedicated piece of physical hardware, and I'm going to install a single application on it called an email server. Oh, I need a file server. Okay, well, here's your file server. And so I would continue to do this based off of whatever my needs were. Now, when you look at this, you probably are thinking, this seems really inefficient. This seems massively inefficient, because what I'm doing is I'm actually deploying a physical piece of equipment for every function that I need in my network. But is that function being fully utilized? Is that piece of hardware being fully utilized? And then us, the IT department of this company, we are having to manage all of these servers. So we're going to need to have some big switch room or server room someplace, and we're going to install all this equipment. We're going to have to manage all this stuff. Fairly inefficient. Let's fast forward to, we'll say the early 2010s. Maybe even, kind of in the, we'll kind of call it more of the 2005 to 2012 time frame. Maybe even a little bit later. So what we're going to do is we're going to deploy something called a virtual machine. Abbreviated a VM. And I'm sure all of you have used VMs at one point or another. You may not have really understood what it was that you were doing, but virtual machines are something that's been around for quite a while, and it's been used in a lot of different scenarios. But in this case, what we're trying to do is we're trying to say, I want to take everything that was here, I want to take everything that was here, and I want to, instead of it being a standalone physical server, I'm going to make it a virtual machine. Now, it's still going to fit a standalone server. It's still going to act and behave in the same way. This physical node 2, same type of thing. Physical node 3, physical node 4, same type of thing. Now, how has our jobs changed in this mythical IT department that we're talking about? Well, now instead of you coming to us and saying, hey, I need a node, can you buy me a server? Now what I'll do is I'll buy that software and I'll deploy it. But I, as a human being, have to make the decision as to which server that this piece of software is going to be deployed on. So that's the first stage of virtualization. So what I've accomplished so far is some degree of sharing. So now my hardware can be better utilized. So I'll call this manual sharing. Phase 1, no sharing. Phase 2, manual sharing. Phase 3, this is hard work. Every time somebody comes up to us, we've got to go and look at all the servers, and we've got to manually decide which server to deploy this software. Wouldn't it be better if we had some type of automation? Wouldn't it be better if we had some type of a cloud environment? And that's what we've been dealing with since around 2012 to, probably 20, I'll even say 18 plus. To some degrees, we're still dealing with that today, where we have a cloud environment. So I don't go and decide which server something is deployed on. I go and decide, I just ask, I want to deploy this piece of software, and my cloud environment decides. Now, all that is well and good. But before I go on to talk a little bit about software containers, I want to draw a picture. So let's imagine that this is a server. And that server is going to have physical hardware. And what I mean by physical hardware is simply that physical piece of equipment that we've deployed. It's probably going to be 19 inches wide, and it's probably going to be 1 3/4 inches tall. And if you were to open up the server, you would see that there is CPU, there is RAM, there is disk, and there are some number of network interface cards, or NICs. I think someone has a question. If they do, kind of put it in the chat, and I can unmute you, I think, so that you can ask the question. So the first thing that we do when we deploy this server is we're going to put some type of host operating system. And the most commonly one used is Linux. Then we're going to deploy 3 pieces of equipment, or three other types of software, not equipment, software. We have something called a hypervisor, something called a virtual switch, and lastly, we have something that we're just going to call cloud agents. And we'll not worry about those so much right now. We might get into that a little bit later. Now, if we want to actually deploy a virtual machine as software, it will have virtual hardware. It'll have what's referred to as a guest operating system. And it'll have whatever that application is that I'm trying to deploy. This is a virtual machine. If you've ever had an opportunity to play with a hypervisor called VirtualBox, then you should be following along. VirtualBox is a piece of software you can install on your computer, be it a Mac or a PC or a Linux box, and it lets you run virtual machines, which are just other computers in software inside of your host operating system. As a matter of fact, one of my hopes for this weekend, I don't know that I'm going to be able to pull it off or not, but one of the hopes for this weekend is I have a scanner. It's a little old. I think they stopped making them in about 2015. And it has software that doesn't work on the latest version of Mac's operating system. So what I plan on doing is I plan on installing a virtual machine of a Windows box, a Windows virtual machine, and then I can install the software on that Windows virtual machine and then use my scanner. That's my hope. We'll see if I am able to get that pulled off or not. Okay. Now, do me a favor, jump in the chat. Talk to me a little bit about what you see on the screen. Is there anything you like or don't like about what you see on the screen? And if you have questions, please feel free to jump in the chat and ask questions. Is there anything about this that seems inefficient or overly complex? And as you're kind of thinking about this, let's draw a second virtual machine, and it will have virtual hardware and a guest operating system and an application. And if I have a third virtual machine, it'll have virtual hardware, a guest operating system, and an application. What is the purpose of the cloud agents? So the purpose of the cloud agents, let me give you a simple answer now, and I'll give you a more complicated answer in a second. The purpose of the cloud agents is if I have some type of controller that is controlling multiple servers, this is the software that lets that control happen. Right, so this basically, these cloud agents basically makes this particular server a worker node in a cloud environment. Great question. Rajesh has got it. Rajesh has really got the key point I wanted to say, which is too many operating systems. Historically, like VM 360, the hypervisor ran on the hardware without an underlying operating system. Do any current systems operate in that fashion? It's a great question, Pete. And you're absolutely right. There's actually two flavors of hypervisors. There's something that's called a type 1 hypervisor and a type 2 hypervisor. And again, that doesn't really help us understand anything, just saying type 1 versus type 2. I think I've got the order right. I may have these backwards. I always get the type 1s and the type 2 backwards. But you're right. There is, if you're looking at VMware, they have what's referred to, I think that's the type 1 hypervisor, and it's also referred to as bare metal. And what they're doing, if I have my hardware, they're saying, no. I don't want a guest operating system and a hypervisor and a virtual switch. The way they would draw their pictures is they would say, I've got this hypervisor. But what's actually happening kind of underneath is they have a very thin operating system just built into this. And they have a virtual switch built into this, as well as the hypervisor. And so VMware is the dominant example of this type 1 hypervisor where it's all one thing. Let me look that up real quick. I don't want to, I keep saying type 1 versus type 2. Let me make sure I'm not type 1 hypervisor. I'm just typing it in just like everybody else. If I have a question, where do I ask my question is Google. And so a type 1 is a layer of software. Oh, yeah, so I've got it right. Okay, good. It is the bare metals type 1. Okay, so then I would have my virtual machines. So Pete, just as you're saying, this is a common way that VMware does it. The way most everybody else does it is the way that I drew on the previous page, where I've got the hardware, I've got the host operating system, I've got a hypervisor, and this hypervisor, the best example of this hypervisor is a hypervisor that's called KVM, Kernel Virtual Machine. It's the biggest hypervisor used in the open source arena. And from a virtual switch perspective, the biggest example we can look at is something called OVS, which stands for Open Virtual Switch. And then someone is saying that Pete must be very old. No, I'm not going to let you get away with that one. VMware is still the dominant hypervisor used in the industry. Okay, so maybe so. I'm very old. That's because I didn't turn my camera on. But VMware is still the dominant hypervisor. So let's not think about type 1 versus type 2 as being necessarily old. It is older. It is the older hypervisor, but that is the key thing. So no, it's a great question. But yeah, I want to go back to the comment Rajesh made a second ago with respect to too many hypervisors. I'm sorry, too many operating systems. Too many operating systems. And absolutely right. I've got a host operating system, and then I've got a guest operating system, each of these virtual machines. Now, let's do the positive thing first. One of the positive things is they could all be different operating systems. That's awesome. But if everybody's Linux, that seems kind of a waste. What would be really nice is if I could still have this isolation, keep these things separate, make them to where they don't see each other, still have some degree of isolation, but let their application run directly on the hardware itself. Directly use the host operating system. One more thing on this, and I think this is kind of the heart of what Rajesh is getting at as well. The operating systems are big and heavy, right? Think of the Windows or Mac or Linux system that you have running on your computer, and then you've got some browser running, and then you're watching this webinar. That operating system is pretty big and heavy. If you are using a Linux-based system, it's probably many gigs that you had to download so that you could install that operating system on your laptop, your server. Very, very large. So on a given server, how many concurrent virtual machines can it support? Because there's a lot of overhead. There's overhead running the operating system itself. There's overhead running each of these individual operating systems. What I really would like to be able to do is I'd like to be able to take whatever this application that I'm trying to run, and then I want to take with it and include all of the required libraries and package that as a single deployable unit. And this is the simplest way for us to think of a software container. And most people just, they don't usually use the word software container. They just usually say container. How can we make sure too many VMs are not created in a physical host? How do we make sure that applications running in the VMs have sufficient resources in terms of computing power and memory? Those are great questions, SJ. Great questions. And I'm going to answer that question right now, but as I'm answering the question, I want you to think about this, not just thinking about it from a virtual machine standpoint. Think about this from the perspective of really any shared cloud environment, because the questions that SJ is asking are relevant whether it's a virtual machine or, as we're going to get to here in a few minutes, software containers. So question one, how do we make sure too many virtual machines are not created on a physical host? Before I answer that, let me draw a picture and say I've drawn an example of a server, and I'm going to change that name a little bit, and I'm going to call that server something called a compute node. And now I'm going to also modify this and say it's not one compute node, it's many compute nodes together. All of those compute nodes are done in the exact same way. They've got physical hardware, they've got a host operating system, and they've got my hypervisor, my cloud agents, and a virtual switch. But now I'm going to add a separate server over here. But I'm not going to call it a server, I'm going to call it a controller. And what this controller is going to do is it's still going to have physical hardware, it's still going to have a host operating system, but now I'm going to start like this, cloud management software. And that cloud management software is going to work with all of the individual worker nodes, compute nodes, and it's going to start to understand how many resources are you currently utilizing. Can you please explain more on Hypervisor Cloud Agent? Yes, I will. So this cloud management software is going to just know how many resources are being utilized on each of these individual nodes because it's having a conversation. It's just like if you're working on a group project, how do you know how busy everybody is? Well, you ask them, hey, are you busy? Can you attend a meeting at 4 o'clock on Saturday afternoon? Okay, so this management software keeps track of that. How do we make sure applications running in the VMs have sufficient amount of resources? Perfect question. When I go to deploy a new VM, I'm going to write down my requirements. Let me write it down like this. I'm going to have my VM requirements. And I'm going to tell those VM requirements to my cloud controller. And I'm going to say, hey, I need this much memory. I need this much processing power. I need this much disk space. And then when my cloud management software goes to make that decision, it knows, oh, you want 200 gig. Well, server 1 doesn't have 200 gig available, but server 2 does, or server 3 does. Now, I'm using this term generically, this cloud management software, and really what I need to do is let's give it a name. And the name I want to give this cloud management software is OpenStack. So just as Pete had pointed out earlier, there are two real systems out there that are being used within our cloud environments. OpenStack, which is an open source cloud management system, or VMware. So with a couple of tweaks, I could draw the same picture, VMware versus OpenStack, and it's more or less the same concept as far as SJ is asking. But that's the real heart of what SJ is asking. It's around this cloud management software, and it's around making a requirement of what you need. Okay, and I think this and this requirement may seem simple, but this is really complex today. If you think about it, I want to build a web server, and I want to deploy that web server, be it on an Amazon Web Service or Google Compute Engine or Azure or wherever. The question really is, how much requirements, what's the demand of that web server? Okay, so if you have further questions, please jump on the chat. Let me go to Kanchan's question, and I think Kanchan's question is really good. He's asking about 3 specific pieces of software. The first piece of software he's talking about is something called a hypervisor, which I misspelled, hypervisor. The second is this cloud agents. And the third is a virtual switch. Let me talk about the cloud agents first. It's the easiest of the 3. They are all software. They are all software. The cloud agents is really nothing more than just a local agent software that works with our cloud controller. Maybe not the best of example, but kind of think of it almost like an ambassador, right? So the United States government has ambassadors that goes to another country, and so that other country, that ambassador is kind of that representative and works with the local people to do whatever. You're going to get tired of me drawing this picture before we're done today. What is the role of a hypervisor? I'm going to just kind of draw it this way for the sake of this simplistic picture, just so it's a little bit easier to see. What's the role of the hypervisor? As I've already said, the most commonly used example is something called KVM. I've got my virtual machine, virtual hardware, a guest operating system. I've got an application. Now let's just use as an example a simple application here. I'm going to have some type of an MP3 player. iTunes or Windows Media Player or whatever that application is. So what is software really doing? Software is running some instruction. Well, that instruction actually has to be processed by a piece of hardware. It has to be processed by a CPU. So my application does something, works with the guest operating system, saying, hey, I have an instruction that needs to be run on a CPU. The guest operating system, not knowing that it's part of a virtual machine, says, okay, cool, let me run that instruction on this hardware. Well, it's not really there. There is no hardware there. So what the hypervisor then does, or the virtual hardware, really is working with the hypervisor, which will then be scheduled and run on a CPU. So the hypervisor's job is to allow for sharing of physical resources. And specifically, CPU and memory are the 2 most important there. Now, this description of the hypervisor, the way I've drawn this, is applicable if I'm talking about KVM or VMware. It's the same type of thing. It doesn't really matter the hypervisor. That's what all hypervisors do, is it takes whatever this instruction that needs to be processed up here in the guest operating system and pushes it into the hardware. The virtual switch is just like what the name implies. So what a switch is something that does networking. Think of the Wi-Fi router in your home. Think of if you've ever used a physical switch or a hub. It's some type of a sharing device. So on this virtual machine, I'm going to have what's referred to as a virtual network interface card. And that virtual network, I just see a blank screen. I'm able to see that I'm sharing, so I don't know MV, I'm sorry. Okay, excellent. So this is a switch. So what the virtual switch is really trying to do is to set up something like this, so that when data flows into the physical NIC card of the server, it goes through that switch and goes to the appropriate virtual machine. And so as you can imagine, to complete the thought, it also, I receive another packet that's destined for my other virtual machine. It goes here. So really, what's the purpose of a virtual switch? This is to do internal switching to machines. But I want you to see this kind of adds to that overhead that is the whole reason to have this conversation, is kind of this extra step here when I'm wanting to process this data. Okay, SJ had a follow-up question. In conjunction to my last question, let's take an example where there are two virtual machines in one host. Okay, we've got that on the page here. And each are 8 cores and 32 gig of RAM. But during a holiday, the application requirements quadruple. In AWS, there is an auto-scaling feature available. But how can auto-scaling be achieved in VMware? The same type of thing, SJ. It's a great question. It is something that's built into VMware. As a matter of fact, VMware has probably been doing it longer and better than anywhere else, anybody else. But you're absolutely right. What you're really saying is, how do I'll kind of draw it this way. What is this virtual hardware here that I've just highlighted in orange? This could be set up to be static. This could be set up to be more dynamic. It could be dedicated or it could be shared. All of those are different considerations based off what it is that you're trying to do. Okay, cool. Now these concepts that I've gone through are very fundamental virtualization concepts. There really isn't anything here that's still not applicable to some degree as we move forward into the containerized world. But let me pause for a second, see if there are any questions, comments, thoughts. All right, cool. So cloud agents, is that part of the VM? Let me go back to one. Actually, let me kind of go ahead and modify this slide just a little bit, just to be clear. I don't want to leave anything kind of confused. This is kind of what I was trying to draw. I can still put cloud agents are not part of the VM. They're part of the server itself. There's software that's deployed. And so these are OpenStack. So in VMware, it's kind of built in. In OpenStack, it's extra cloud agents. It's extra software that's added. Very similar to a hypervisor, yes. Would you please explain the software container once again? Okay, I haven't really gotten to that yet, so it's a good question. That's exactly where I wanted to go to next. And actually, let me draw it this way because I think this is the best picture. And just as you guys have already pointed out, I've got too many operating systems. These operating systems are big. What I would really like to be able to do is I'd like to be able to have whatever this application is running on this host operating system using the CPU. I would like this application, whatever it is, to really be running on this host operating system on the CPU. So if I take the same picture and start with hardware, start with my host operating system, Linux, I'm going to kind of put over here in the corner something called a Runtime Engine, and I'll come back to that in a second. And now what I can do is I can take my application, I can include any required libraries, kind of package that up in a box, and now I can deploy it. That's a container. Now what I want you to compare is I want you to compare this virtual machine to this container. Which is bigger, the virtual machine? Because I've got that extra operating system. So when we talk about containerization, and that's a term you'll hear as well, containerization, this is what we're talking about. Taking this app and just the very minimum of what's required for, from a required library so that it can run on this Linux operating system here, or whatever the operating system is. So SJ, that is a container. That is a container. Much smaller and much easier to deploy, less overhead. But it doesn't come without its challenges. So what's a runtime engine? A runtime engine's job, so over here I said there was this thing called a hypervisor, and the hypervisor's job was to kind of help share the physical hardware. Well, runtime engine, what its job is to do is really to help launch a container and monitor that container. Let me give you the best example I can give you of a runtime engine, the runtime engine that's used most everywhere that I've seen, which is Docker. So that's a runtime engine. Where would the database management system run? Or would it be separate or a dedicated server? That's a great question, Red. And it really depends on the problem you're trying to solve. So is there a database of some form built into Docker to manage all of the containers that are running? Yes. Is that really what you're getting at? Probably not. We'd have to look at the specific service. So for example, if what I'm trying to do is I'm trying to deploy a piece of equipment or a service that needs a database, then it's going to have its own database built in. That database might be built into the same container or in a separate container. So if you're dealing with something like an Amazon storefront, what that probably is a whole bunch of database front ends, just as Neat is saying, or no, he's saying something else. But it's a bunch of database front ends going to the same data store, which is replicated for the sake of supporting that database functionality. Is it on a separate server? Maybe, maybe not. What a lot of people do, and I'm really simplifying this hardware discussion here. What a lot of people do is they'll have a set of servers that are dedicated as their storage nodes. And then they'll have some specific software that's running on those storage nodes so that you can get replication and you can get redundancy and you can get recovery and you can get migration. And so there's a lot of different ways. Now, I don't know exactly how Amazon has done it, but my suspicion, since they're such a large cloud, they probably have a set of servers dedicated for storage, which is a common thing within large clouds. Nitin is asking, is Docker daemon process act as a runtime engine? That's exactly what it is. So if you've ever used something, Nitin, with where you're getting the Docker daemon running, the Docker daemon is doing the job of that runtime engine. Now, if you're using Docker and you're going onto a server and you go onto the command line and you say something along the lines of Docker run, and you give it a name, test, and then you give it a name, you say, and I want to run a specific image, and the image is, for example, Ubuntu, then what this command line interface command is doing is it's saying, hey, Docker daemon, you need to run, we're going to name of test, and we're going to use the image Ubuntu. Now, this image may be local. If so, great. We'll use that local image. If it's not local, then we're going to try to do a pull from some repo. By default, it's going to be a repo called Docker Hub. But yes, that's exactly what the Docker daemon is doing, is it's receiving Docker commands and it's then turning that into some type of action to deploy a container. No, great point, great question. And if we go back into our slide for a second, that's really what this is trying to show here in this cloud native world. This is more of the containerized. And this is happening as we speak today. And so we want to kind of go a little bit deeper in that as well. So a couple of examples. Let me run through a couple of slides, and if you do have questions, please feel free to jump, put them into the chat. But if I had a telecom function, and a common telecom function is called an MME, or a mobility management entity. What the MME does is it's composed of a number of subcomponents that are, their job is to manage mobiles in a cellular network. And so I have some operation, administration, and maintenance. I've got some controller functions. I've got something called bearer management, which is dealing with things like establishing data sessions. So when you go to receive your email, that's a data session that has been established. When you go to, look at Facebook, or you go to log on to watch a video online on Netflix or YouTube, you're establishing a data bearer. And so if I were to put these into virtual machines, what I may say is each one of these are their own standalone virtual machines. All I've done is I've kind of taken my original architecture and I've ported it. And this is a very common approach. But each of these different services can be quite large. And I've already drawn pictures similar to this. We're talking about kind of pre-virtualization. We were just installing the apps, virtual machines, and then containers. Kanchan has a question. How much resources will you save by doing containers versus virtual machines? It's a great question, and I can't give you a great answer. It depends on the nature of the solution. If I'm doing a very simplistic solution, like I've got some Python code that I want to run, then if I have to deploy a virtual machine to run my Python code, it's probably 95+% overhead. So if I could do that in a container, that's a huge, huge savings. If I'm doing something that's a lot more complicated, maybe it's only 80% overhead. Maybe it's only 50% overhead. So it really depends on what it is that you're doing. But a simple example, when we do training on containers, there's a simple example that we end up doing. And the simple example is this. I look at the host operating system, and I look at how many processes are running. And what I'll see is if you have a system that's fairly small and it's not really doing a lot, I'll have, approximately 150 processes that are running. If I go and I do the same thing from inside of this container, and this kind of gets us to this minimal guest operating system, this is just that bare minimum that you need to work. What are those few libraries that you need to work? I can have this as small as less than 10 processes running. So there's a lot of stuff that's running that I don't need. And that's really what I mean by that minimal guest operating system that we see here in this. Wouldn't having too many containers harder to manage and having less number of VMs? You're absolutely right. So we need to have, that's a really good question you're asking, Kanchan. I've made this individual deployable unit more efficient, but what do I do to manage it? And we'll talk about that in a second. Now, there's two real use cases. Are you using minimal OS and bins, libs interchangeably? Yeah, I really am. Because really, if you think about what is an operating system, it's just a collection of libraries and binary files. So I am using those a bit interchangeably, maybe a little bit too much ROI, maybe a little bit too much. That's a fair question that you're asking. So let me give you the best example I can come up with of a container. So what you see on the screen is me typing in something into Google, and I know all of you guys do this all of the time. What Google is doing is as soon as I hit enter, it's going to launch a container. Now, where's that container? I have absolutely no idea. It's on Google's cloud someplace. It could be in California. It could be wherever they have cloud computing. Right? So I hit return. A container is run, and it runs the Google software. So what's inside of that container is the Google software, the Google search algorithm. At the end of that, of doing the search algorithm, it presents the results, and then it destroys the container. So how long did this container live? Well, it actually gives me an answer. 0.51 seconds. So in the time I hit return and I got the results, we spun up a container, we passed in the search criteria that I provided, we ran the search algorithm, and we got the response back, all in half a second. That's what a container is doing. That's what a container is doing. It's not doing anything else. It's not doing anything else. So when you think of a container, I always like going to Google because it's such an easy example. Now, you'll see a lot of people using as an analogy a shipping container. And there was actually an article that came out a number of years ago that talked about Google using billions of containers, and somebody misunderstood them and thought these types of containers. They thought these big shipping containers, and Google just had billions of these things around. No, it's an analogy. What a container is a collection of pieces of information that need to be run together. It'll have some type of a container manifest. That container manifest will have some number, what are the contents? How do I put the data into the container? Origin of the container, destination, capabilities, and any specific labels. So when you think about a container, before we get to kind of this virtualization concept, the first use case of a container was a software distribution. How many times have you went to try to deploy a piece of software on your computer and you didn't have a required library installed? I'm sure you can't count the number of times. I'm debugging a problem right now in one of my labs, and I think it has to go to the fact that there's a piece of software missing, and I can't figure out which piece of software it is. Everything pretends like it runs, but it doesn't actually work. So what a software container, its original job was to say, I want to take away that worry. What I want to do is I want to say, I'm not going to depend on the Linux operating system. It was originally designed for Linux. I'm not going to depend on the Linux operating system. I'm not going to depend on you having a whole bunch of prerequisites set up. What I want is I want to include within my container whatever the application is and whatever those required libraries are. And I want to package that together, and I'm going to call this the app 19. And so when you go to try to do a Docker run of the app 19, you don't have to worry about anything else. You don't have to worry about the fact of which version of a library you're using. And if you've had the opportunity to program with Python, you know exactly what I'm talking about. I had an issue 3 days ago. I was teaching a class, and I went in, and the code I needed required version 1.11.1. And the version that was in my host operating system was 1.9.2. So before class, the first thing I had to do was I had to upgrade the software for this particular package. In a container world, I would have just included inside of here version 1.11.1. I don't care what's down here in the host. I'll put what I need here. And the only place it's visible is inside of this container. So I may have version 1.11.1 here, and I may have version 1.9.2 here, and I may have another container over here that's really old, and it requires 0.3.9 because in 0.4 they changed something with the API and the application doesn't work anymore. So that's containers from a software deployment standpoint. Now, I'm making a very interesting statement here, and I don't want you to lose this. The statement that I'm making here is the fact that I can have an environment for this container that is separate from everybody else. So in essence, I'm building kind of an extra layer of fencing around this container so that I can isolate what binaries it uses versus everywhere else. When people say image, is that the same as a container you were talking about? So we use the term image. It's a great question, RY. We use the term image in a couple of ways. I could mean image to be a disk image or what we would use to launch a virtual machine. I could mean an image to be a container. Typically, we use the term image to mean that collection of software that needs to be installed, or that collection of software that needs to be run. So yes, I would say that this is a container image. And a container image is just a collection of bits. And that collection of bits will be however big it is. It could be 100 meg, it could be 5 gig. And then I can use that however I want to use that. Does that make sense? But yeah, that's really typically what people are using as an image. Image is a class. An image is to a class as container is to an object. Is the way I like to look at it. Okay. Okay, yeah, that makes sense. That makes sense. So an image may be a class. I kind of think of the image as kind of the and I think the way you're thinking is a good way. So an image is that software, and a container is a running instance of that software. But we're kind of saying the same thing. But yeah, no, it's a good way of thinking about it. Good way of thinking about it. Can a container have multiple images? So not really. So typically what we're going to do is when we package this container up, we're going to say that that has some, as we are implying here, it has some manifest, it has some characteristics, some contents. Now I could update that, and I might have different images with different version numbers, but really an image, a container will be a image. In the same way a virtual machine is a image. So no, that's a good question. Okay, so I want to take this a little bit farther, and this is really the key thing I wanted us to talk about with respect to containers. Let me see, do I have a slide that helps me with this? Yeah, okay, we've talked about this. And actually, this is the same thing you were just asking. A container image is that blueprint. You can kind of think of it as a container at rest. And then a running container is actually just an instantiation of that. So kind of goes along with just the conversation we were just having. And we talked about this. And then we've talked about this. Oh no, this is where we want to go. Okay. I want to go back and I want to talk for a second about this, what I've been referring to a little bit as guardrails. So I say I've got an application. It's got some number of required libraries, and I put a box around this. And let's just say for the sake of argument, I'm putting multiple boxes. I have another application. I'm going to put it as a different color. application libraries node image, MongoDB image, combined into web app image. So that's a good point. You might do that. I might take a some type of I could build a new images if I wanted to. And you can think of that as really that container at rest. So you're building that manifest. You're putting all of that software into this image. So yes, I could do that. But I'm, again, making a conscious decision to kind of do that combination. Can containers replace 100% of VMs, or will there always be a place, for we still need VMs? That's the million-dollar question. If you talk to the people who really want to deploy containers and get rid of virtual machines, they would say, yes, we can always, everything can go into a container. So far, we haven't seen that in practice. So are we going to have virtual machines in the next? Probably yes. Are we going to have it 10 years from now? I think so, but I don't really know. But at some point, a virtual machine will probably become less utilized over the course of the next decade or so. I can't really give you too much more than that. Okay. So I've drawn two containers, and for the sake of this discussion, they're on the same physical server. Now, we've already talked a little bit about physical servers. We've said physical servers are composed of three different types of physical resources. We've got CPUs. We've got something related to memory, right? So RAM and disk. And typically, we kind of combine them into one thing. Even though RAM and disk are different, we kind of combine them into one thing. And then we have something related to networking. We also have a host operating system. And if I think about a host operating system for a second, host operating systems are composed of a number of directories. And those directories have files. And those files may be binary files, bins. There are some files that are really private and we don't want them shared with anybody. For example, I might have something that has our password file. And this has all the passwords of all of the users that's allowed to access the server. There's other pieces of software that if somebody were to mess with that software, it could cause a lot of damage to this server. So even though I want to allow this container to run in my host operating system, I really need to come up with a method that allows me to limit what this container is allowed to see and access. The thing that does that limiting, the concept that allows me to limit what a container can see or access is called a namespace. So in other words, what's happening, and it's a software construct, what's happening is when I deploy a container, it's actually within a namespace, and a namespace has resources that it's allowed to use. Let me give you my favorite example. What is ping? You've probably used ping. If you've done anything within the computer science space, within the networking space, you've probably used the application ping countless times. But what is ping really? Well, ping is a program. It's a binary. It's a piece of software. And that ping actually lives in a directory called bins for binary. And so if I go to a command line and I type ping 8.8.8.8, it goes to the directory and it runs that piece of software. Okay, not a hard concept. We get that. So I log into this container and I run the ping command. Will it run? And your initial instinct is probably, well, yeah, the host has it. And that's my point. My point is this ping based off of the description of the namespace, is that visible inside of this container? Is this network interface card visible inside of the container? How many CPUs can I use within this container, within this namespace? What memory can I use and access within this container, within this namespace? So the namespace is the concepts that's used to really build this fencing around these containers to allow this degree of isolation so that one container shouldn't have the ability to impact or influence another container. Let me pause for a second. Questions, comments, thoughts. That was one of the key things with respect to containers. We've got this thing here called namespaces. We've got some other Linux constructs as well, something called control groups and security features, and those are, again, going to be used to limit what a container is and is not allowed to do. And every year, every version of Linux, these are better and better and better. Great question. RY is asking, is the namespace functionality provided by the Runtime Engine? Think of the Runtime Engine as working with the Linux operating system to get these namespaces set up. So if I go back over to the picture, actually I can do it right here. So I can say I've got, so this kernel, this is really the host operating system. I've got my container engine here, and what it's going to do is it's going to interface with our Linux operating system to do things like configure a namespace, add a namespace, delete a namespace. So that's one of the things that Docker would do. No. Why are you distinguishing between containers and the host and container processes? I'm distinguishing between containers and the host and container processes is because processes is what the container is actually able to see. So think of that fencing as saying what processes a container is allowed to see or not. If I can't see it, I can't interact with it. It's kind of like if I were to come up to you. So you're living someplace, wherever you're living. I live in a house in North Plano, and there's 5 people that live in this house. And I'm currently in my bedroom / office. And so could my kids walk in here? Well, they can, but I tell them no, don't walk into my bedroom. That's a good example of a namespace or a container. What I'm doing is I'm using not technology or not physical technology. I'm not putting a lock on the door. I'm not barring the way, but I'm basically saying you can't go into my bedroom. As far as you're concerned, you can't see it. It's a wall. There's no door there. Now, because of that, for all practical purposes, if I were to say to them, how many bedrooms does the house have? In reality, they could say 3, because one bedroom they don't even see because it's my bedroom and they're not allowed to go in it. That's what I mean by this. So therefore, they don't know what's in that bedroom. They don't know what's available. They don't know anything about it. That's what a namespace is trying to do, is to try to limit what can be seen inside of a container to provide that isolation. Imagine if inside of a container, I could affect that Docker daemon and I could kill that Docker daemon, I would do a lot of damage to this node. So great question. And we talked about this. But let's talk about this for a second. I've got a couple of things I still want to do. I want to wrap up here in the next few minutes. I've got one more topic I want to talk about. But let's go here, and I want to go to something called Docker Hub, just so you can kind of see an example. So what Docker Hub is this is a set of containers that people have put into a public repository. If you're familiar with GitHub, kind of think of GitHub as more of a development environment, and Docker as more of a where containers live. And so let's go and say, so someone asked about a question. Let's go and say, I want a MongoDB database. MongoDB hit return. And so I have a Mongo database. It's had over 10 million downloads. It's got 6.8 thousand stars, and it was last updated 9 minutes ago. So this is that container. This is that container. And so if I wanted to, I could go to a Linux system and I could actually download this container and run it. And I would have a MongoDB running. I don't have to install anything. I don't have to do anything other than pull this container and run it. That's what a repository is doing for me. All right. One more slide, one more concept. I know you can't read this slide. This is something it's been put together by the Cloud Native Computing Foundation, CNCF. And this is actually, I'll put this in the chat if anybody's interested. This is l.cncf.io. And this is what's referred to as a landscape, a software container landscape. And what I want you to see is I want you to see the number of boxes that are there. And these boxes each represent a project of some form. That project may be open source, it may be proprietary. But I want you to see how popular the container field is. Now, what we've been talking about with Docker is a runtime engine. And so you can see a number of boxes here in the very middle, and they're all examples of runtime engines. And I say Docker is one. Docker actually is kind of a wrapper around one of the ones that's here. We've talked a little bit about networking. Networking is very challenging. So here is the cloud native networking. Storage, how do I store data? How do I have persistence? Cloud native storage. And then the last thing I want us to think about is with respect to orchestration. How can I have 10, 100, 1,000, 10,000 servers, and I can put containers on all those servers? I'll use some form of a cloud orchestration system, and it's a little hard to see, but right here in the middle, you'll see there's something called Kubernetes. And that really leads us to our last concept. And if you understood what OpenStack was doing, then this is going to be no big deal. So within telecommunications as well as within computer science, we're kind of lazy. We don't like to write out big, long words. And so we usually like some type of an abbreviation. So you may see as an abbreviation for Kubernetes, K8S. And where that comes from is they kept the K, they kept the S, and there's 8 letters in the middle. So instead of writing the 8 letters in the middle, we just write an 8. What is Kubernetes? Well, Kubernetes is very similar to what we saw with respect to OpenStack. So if I have a server, that server is going to have hardware, host operating system, and a runtime engine. I'm actually going to add in here, I'm going to have also with this something that's called a master node. And that is going to run, it's going to have hardware, host operating system, and that's going to run this Kubernetes software. And this Kubernetes software is going to interface with some agents, just like what we saw in OpenStack, to launch containers. And in a perfect world, I could have hundreds, thousands, tens of thousands of servers managed by Kubernetes. Kenton likes the abbreviation. Excellent. So Kubernetes is what's being used to manage large numbers of servers and deploy these containers. So just like what we started our conversation with an hour plus ago, I as a human being would come in and I would say, I want to launch a container. And so I would run a command and I would say, this is the particular container I want to launch. And what Kubernetes would do is it would say, okay, I've got 1,000 nodes. I'm going to pick node 412. Why am I using 412? For whatever reason. And then we would deploy that container on server 4012. From operation or system admin point of view, isn't it too complicated to have too many nodes? You're absolutely right, Kanchan, but it also is too complicated if I have too few nodes and have to have too many Kubernetes instances. Think about this if I'm a major operator. If I am an Amazon, if I'm a Google, if I am even a telecom operator, an AT&T, a Verizon, then what I'll need to have is I'll need to have thousands and thousands of nodes. How do I want to manage those? As a big cloud or as a bunch of little clouds? May depend on the individual operator. So it's a good question. SJ is asking the question, does it mean Docker is not a competitor to Kubernetes? That is absolutely true today. Today, what we see is them working together. Docker had a competitive orchestration technique. That competitive orchestrator has since been kind of de-emphasized, and Docker and Kubernetes are working very closely with each other. So yes, today, most people are deploying Docker on all of the individual servers, and then Kubernetes to manage that group of servers. And so let's talk about this one. We'll use this as our concluding kind of discussion. Pros and cons. And I could ask you your opinion at this point. Pros, containers are technologically superior. They do have a faster spin up. They have higher application density on a server, more efficient from an application execution environment. They're easier to recreate. So I create if I give each one of you a container, I don't have to worry about the fact that RY has version 2.7 of this piece of software and Nitin has 1.4 and whatever. I could say everybody has the same version. We're all using the same version of Python, and we're using the same version of whatever libraries that are important to us. And as well as I don't have to worry about how long ago you did it, software, how to do the software distribution. The biggest con is security. So I used as my analogy, I've told my kids they cannot go into my bedroom. They're not allowed to. But what's really keeping them from doing that? It's more of just the fact that I've said it. Because we're using software to control these containers, it could be that someone could eventually break out of those containers. And if breaking out of that container, they could get access to stuff that they're not supposed to have. So one of the cons of security is the fact that we are actually running the host operating system. Our application is running, and if it's a bad app, it could cause a problem. And that is at least a little bit of an introduction on containers. Questions, comments, thoughts? If you are interested in getting more into containers, there's 3 things that you need to look at. And there's just 1,000 tutorials out there. And if you have any specific questions, feel free to contact me. Probably the easiest way to find me is on LinkedIn. But the 3 things that I want you to do research if you're interested in this is Docker, Kubernetes, and then if you want to deploy your own little Kubernetes cluster so that you can play with this, look at something called Minikube. Minikube is a standalone, kind of pretends to be a cluster, but lets you run all the Kubernetes and Docker commands. So therefore, you can actually do most everything that you could do in a real system, but it's in your own environment and you can play. Question Nitin has, is Docker Compose final step before a jump to Kubernetes? So what Docker Compose is really all about is trying to build a Docker container, not launch a Docker container. So we talked about how a Docker container we have a container, and we need a bunch of things in that container. So for example, I need to say what libraries are in this container. What files are inside of this container? What application is inside of this container? How do I build this? Docker Compose is a way of doing that building. And so I'll typically use Docker Compose if I'm trying to build something and deploy it locally. It's not so much like Kubernetes trying to manage large-scale deployment. And I like our Google search example we did a few minutes ago, where I said, Google search, I go and I typed in something in the Google search bar, I hit enter. There was a Kubernetes agent someplace. And again, Google was the initiator of Kubernetes. They pushed it into open source. They use something similar. Google takes Kubernetes, launches a container with my search criteria on one of 1,000 or 10,000 or 100,000 servers and gives me the results back. Docker Compose is more about what does a container look like? What's the nature of that container? Does that make sense, Nathan? All right, excellent. You're a very good and passionate teacher. Thank you. Okay, so what we need to do, we don't really have time today, but the next time we get together and do something like this, and I'm more than happy to do another one of these, what we'll do, now that we've talked a little bit about what containers are, let's actually look at deploying some. I could deploy some in, I could just show you some examples within a lab very easily. If you're interested in doing this for yourself, please look up Docker, Kubernetes, Minikube. There is 1,000 tutorials out there, and just go play. The only way to learn this stuff is to just go in the lab and play. So if anybody has any more questions, please feel free to jump in the chat and ask. Otherwise, thank you guys so much. Finish up whatever you need to finish up today and get started with your weekend. It is Friday. I know sometimes we lose track of days, but it is actually Friday today. What makes a good app container and what makes a bad app container? That's a great question, Tom. A good app container is going to be self-contained. It's going to provide some function. A bad app container is going to be something that has a lot of dependencies outside of itself. A bad app container is going to be something that's very large and it has to do a lot of different things. So typically from an architectural design standpoint, what people are trying to do with containers is to make them more single function. So don't think about the fact that I want to have a web server that is going to provide the accounting information and the ability to change your profile, blah, 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 blah. Think about the fact that I want a container that is presenting security. Or if you think of something like Twitter, every box in Twitter or in Amazon, all those little individual pieces of software that's presenting other people also bought this, or if you buy this other thing, you can get a 20% discount. All of those small little functions is the best thing to think about for a container. Self-contained. A container and a business function match? It could. It definitely could. It depends on the specific application that you're trying to deploy. And I know that's a bit of a cop-out answer. I don't like that answer either, but unfortunately it's the best I have. If we were to look at a specific use case, if I had, there's 27 of us on this call right now, all 27 of us could come up with a different architecture for it. And so really the only thing I can say from a guidance perspective is to make the functions as small and atomic as possible. Thank you, SJ. That was a great comment. Thank you. Thank you, Neaton. Thank you, Tom. How to convert a fully functional VNF into clusters and containers? It's a very good question, Rajesh, and that is the million-dollar question. That's what the Ericssons and the Alcatel-Lucents, or not Alcatel-Lucent anymore, the Nokias, the Meta switches, the Hewlett-Packard Enterprises, everybody that's trying to develop software, what they're trying to do is they're trying to take an existing physical piece of hardware, convert it to software only, and then decompose it into containers. So that is a huge, huge challenge. And it is really a very difficult re-architecture. So basically you asked me a question how it could be done, and my response is it's hard. Sometimes the questions are better than the answers. It is an extremely good question, Rajesh. Extremely good question. And there's a lot of people all around the world asking that same question. And they're making decisions, and they're developing it, and then they're making new decisions because they didn't do a good job the first time. Yeah. Any other questions? Well, guys, I want to thank you so much for taking time out of your busy schedule to listen to this. If you enjoyed it, thank Jay. Jay asked me to speak. More than happy to come back and do it again. And again, we can do something on kind of a little bit more of a hands-on, logging on and doing things sort of a talk at some point in the future.